These notes are going to cover the different equations in section 3.2, which will probably make more sense when we do problems, but we'll go through the equations and when they're used. So all of these equations are used when something is accelerating, when it has some acceleration number, like 5 meters per second squared or -3 meters per second squared. So this first one is for calculating a velocity when you know the acceleration and the time. So you can find the change in velocity or the final velocity. Here are the equations for that. So we have final velocity is equal to initial velocity plus the acceleration times the amount of time that has gone by. Okay, then the next thing I want to talk about is that you can also find the time, or sorry, the change in position if you know the acceleration. If you have the velocity time graph, then technically you could use the graph to find it, because you could find, like, you would have meters per second over here on the y-axis. If you think about it, you would have meters per second and then seconds down here. And if you do the area, you would be multiplying units, right? So you'd have meters over seconds multiplied by seconds, and you'd end up with meters, which is a position. So doing the area between the graph, like this green line, and the x-axis, or even like this is a graph in quadrant 1, even if you had a graph in quadrant 4, like that was in, the negative territory, you could still do the area. It just wouldn't be the area underneath, I guess. It would be the area like above the graph then, right? But the idea is the same. So you would be finding that area, and then that would tell you how far that object has moved in that amount of time. So that's a way to do it, but then we also have the formulas, and we also have the position time graph, right? So you can just, which is going to be a parabola in this chapter. So if you want to know a position at a certain time, you can just find, okay, well, I am at this particular time. I'm going to solve for the position, okay? It's just that that's a quadratic function now if you're using the position with respect to time function, okay? So if we look at those formulas, then you have the final position is equal to the initial position plus, okay, we got all this, and you will notice that this is a quadratic function, right? That's this parabola that we just looked at, okay? I mean, it's maybe not the right side of the U. We've got all different possibilities that were in the packet that we talked about. Maybe it's the rainbow function, okay? Or maybe it's the left side of the U. But no matter what it is, you can solve for a particular position at any moment of time just by plugging that in if you know the time, okay? Now, what if you don't know the time? So if by combining formulas, okay, and if you're a math nerd, you can do this, you can use substitution. You could get an equation that doesn't have time in it. And so then you would get this version of the formula. And this represents displacement, df minus di. So you could take this out and call it delta d. Okay? So that's the last formula, I think, on our page. So then when we put those all together, we have what's on your blue formula sheet. All four formulas. Really, these two are the same. They're just transformations of one single formula. okay? But then these are the four that you can choose from.